Injection molding is one of 7 common plastics processing techniques for production of industrial and consumable plastic components. This process is a fast cycling process with high output and is considered one of the most important processing techniques in the industry. Injection molding is a process of cavity filling with the application of heat and pressure. To begin this process, we will need the raw materials. Thermoplastics, usually in granular or bead form, are generally used. The base plastic will make up most of the material. Then we add any colored plastic if it is necessary to achieve the desired outcome. After the plastic has been mixed, it can now be ingested into the machine by a vacuum system. The beads travel through the vacuum hose into a hopper placed on top of the injection molder. Once the hopper is full, a sensor will automatically stop the vacuuming process. Next, the material will need to be heated to an impressionable temperature. The plastic will first pass through a magnet before it enters the barrel. This magnet will remove any metallic impurities to ensure a quality product and to keep the machine functioning properly. Inside the barrel is thick steel piping retrofitted with heating bands to facilitate the heating process. Further inside the barrel is a steel reciprocating screw machined with a specific configuration to assure the material friction is at an optimal level. A one-way valve acts as a plunger, producing up to several thousand pounds of pressure during the mold filling. Once the plastic is at a favorable temperature, it can be pushed through a nozzle attached to the end of the barrel. This nozzle acts as a channel for the flowing of molten plastics into the mold. Once the halves of the mold converge, the plastic can flow into the designed crevices to be formed into the desired shape. The plastic cools, solidifies, and is then released from the mold. This process can be used to make an array of useful products as shown here. From window scrapers, to plastic golf tees, to keychains, to giant paper clips. The laser may be one of the most important technological discoveries in the last century. Lasers have been used in a great number of applications in the medical, military, and industrial fields. This laser allows concentration on a very small area, generating an impressive power density exceeding several million watts of power per square inch. This is powerful enough to melt or vaporize most of the industrial materials in its path, including composite, metal, plastic, and ceramic. This automatic process runs by entering information into a computer, converting everything into a code which the machine follows as it cuts. This assures the precision of all cutting and engraving. After the machine is told where to cut, the material needs to be aligned and secured to keep it in place during this process. Power adjustments before the process are necessary so the laser knows whether to cut or engrave. The laser will move along the designated path until complete. Materials can often have a paper covering which may burn during the process, and any smoke can be removed via a connected ventilation system. When all cutting is done, we can remove the materials, clean out any waste, and view our final product. The roll-fed thermoformer is a highly sophisticated machine with high output. The most common type of product is consumable single-use packaging. This process uses a soft and flexible plastic ranging from 1/16 to 1/8 of an inch thick. A pneumatic system is used to unwind the plastic, and a chain mechanism is responsible for transporting the plastic to the next station. To do this, the chains have little teeth which grip the plastic. The plastic is first pulled into the oven to be softened. Once it reaches the processing temperature, it can next move along to the molding station. Aluminum is the most common type of material used for the mold. This mold is moved into the plastic, activating a vacuum system, which forces it to conform to the mold's design. Next, it can be pulled along to the cutting station. By the time the molded plastic reaches the cutting station, it has already been cooled and hardened. The cutting station converges, separating each individual product one at a time. The trimmed parts are collected manually at the end and stacked while they wait to be used or shipped to a customer. These products can be used to package just about any consumer product that you can think of. Thermoforming is a plastics processing technique which uses heat, pressure, and vacuum, and/or mechanical force. Thermoforming is considered one of the most progressive sectors of the plastic industry, with a good possibility for substantial growth in the future. The advancement in this technology has increased productivity and quality in the field. The materials needed for this process include the mold and the thermoplastic sheet, with a thickness ranging from 1/100th to 1 inch. Here we have an older and newer model of thermoformer. This sheet is secured in the machine with a clamping mechanism and is moved back into the oven where it is heated, which softens it to an impressionable state. And the sheet emerges from the oven and moves back into position over the molding station. The mold can be made from a number of different materials, including wood, metal, or ceramics. This mold station is then moved up into the sheet and a vacuum system is activated, which ensures that the sheet will conform to every crack and crevice in the mold design. The mold is removed from the sheet and the excess plastic is trimmed to meet the final specifications. This type of plastic processing is generally used for consumer products, including toys, packaging, and many other products that we use on a daily basis.